Let us try to understand one more property of Boolean algebra by taking this example. So, f1 is function of ABC whose mean terms are 1, 4, 6, 7. f2 is also a function of ABC whose mean terms are 1, 2, 4, 7. f3 is function of ABC whose mean terms are 3, 5, 6, 7. And I am defining one more function f, which is f1 plus f2 bar f3. Obtain the mean terms of f bar. So what is the mean terms of f bar we are supposed to find? So first we'll find the mean terms of f. Once I have mean terms of f, how to get the f bar mean terms, we know that logic. So here, what we'll be doing, student, is, so for example, okay, so f1 having 1, 4, 6, 7. So if I ask you what is f2 max terms, because here f2 bar is used, f2 max terms are nothing but those are missing number, those are the max terms. So what are the missing terms? You have 0 missing, 3 missing, 5 missing, 6 missing. So f2 having max term 0, 3, 5, 6. So if I ask you define f2 bar, so what are the mean terms f2 bar? So max terms of f2 becomes mean terms of f2 bar. So max terms of f2 are 0, 3, 5, 6. So mean terms of f2 bar will be 0, 3, 5, 6. This is 0, 3, 5, 6. So in place of f1, let me write what is given here, 1, 4, 6, 7. So direct, okay, let us do this way. 1, 4, 6, 7 plus f2 bar. f2 bar means this mean terms I am writing. Mean term 0, 3, 5, 6 and ANDed with f3. So f3 mean terms are 3, 5, 6 and 7. So this is mean term 1 plus mean term 4 plus mean term 6 plus mean term 7. Then you have mean term 0 plus mean term 3 plus mean term 5 plus mean term 6. This is ANDed with mean term 3 plus mean term 5 plus mean term 6 plus mean term 7. Now this is mean term 1 plus mean term 4 plus mean term 6 plus mean term 7. Here one important property which you have learned, we will be using that. There is mean term I ANDed with mean term j is equals to 0. If I and j are different, mean term I ANDed with mean term j will be 0. So student, here you see, if I will be expanding it, so plus what you get, mean term 0 ANDed with mean term 3. I mean, like normal multiplication, mean term 0 with mean term 3 plus mean term 0 with mean term 5, mean term 0 with mean term 6, mean term 0 with mean term 7. So first I am doing for this, for the remaining one we will get the pattern, we can easily come to the conclusion. Mean term 0 dot mean term 3 plus mean term 0, mean term 5, mean term 0, mean term 6, mean term 0, mean term 7. Okay, and these all terms are 0 because mi and mj are different index, this is 0. So this is 0. Then plus, again we'll be doing this with mean term 3, mean term 3, mean term 3, mean term 5, mean term 3, mean term 6, mean term 3, mean term 7. So this is 0, this is 0, this is 0. So you are left with mean term 3 with mean term 3. But we also study the property mean term I ANDed with mean term I is same mean term I, right? So this will give me mean term 3, right? Similarly, for 5 and 6 you can do it. So what you are going to get is, so all terms will be 0. So if I am doing with mean term 5, so mean term 5 with mean term 5, so I will get this one, mean term 5 plus mean term 5. Remaining all terms will be 0 because mean term 5 with 3 is 6, 7. So based on this, what will be 0. And lastly, if I try with mean term 6, so again mean term 6 is present here. So mean term 6 with mean term 6. Remaining all terms will be 0. So the final answer is m1 plus m4 plus m6 plus m7 plus, from this you don't get anything, it is 0, plus from this you get mean term 3, from this you got mean term 5, and from this you got mean term 6. So that means if I ask you to write in a compact form, so you know 1 is present, 1 is present, 2 is not present, 1 is present, 0 is not present, and 2 is not present. Whether 1 is present? Yes. 3 is present? Yes. 4 is present? Yes. 5? Yes. 6? Yes. 7? Yes. And although I have mean term 6 and mean term 6, again mean term I plus mean term I is again mean term I. So mean term 6, although it is 2 times, mean term 6 plus mean term 6 is again mean term 6. So I have everything except this 0, 2. So it is 1, 3, 4, 5, 6 and 7. So this is what is your F is. This is what your F is. F mean terms is this one. Then if I ask you what are the max terms, so max terms of this will be 0 and 2. Those which are missing, they will be max terms. So this is what your F is. But you are supposed to tell the mean terms of F bar. So we have already seen max terms of F becomes mean terms of F bar. So if I ask you to describe F bar, so F bar mean terms will be simply 0, 2. If I ask you what are max terms, so mean terms of F become max terms of F bar. So max terms will be 1, 3, 4, 5, 6 and 7. So this is the answer, F bar. But the point I want to tell you, student, here is, see, let us first concentrate this particular F2 bar, F3, okay. So F2 bar, F3 is given by 0, 3, 5, 6 and F3 is given by 3, 5, 6, 7. You see, if you observe this square bracket term, what I got is, at the end what I got is, so I got mean term, what I got? I got mean term, I mean this is what I got actually. I got mean term 3 plus mean term 5 plus mean term 6. I mean this bracket, if you see the way we have manipulated, at the end what I got is, I got 3, 5, 6. So if you see, this much of drama is not needed. So whenever you are doing the AND combination of two functions, AND operator works like a intersection operator. You have studied the union and intersection concept in your set theory. So while finding the intersection, what we do? We take the common terms, and while taking the union, we collect all the terms. So AND operator is always equivalent to intersection operator of set theory. So here the common terms are 3, 5, 6. So that's why it is giving you 3, 5, 6. So and overally it is OR. So OR is equivalent to union. So union of 1, 4, 6, 7 with the common terms of this. So that is what you are getting. Because this overall answer is union of 3, 5, 6 with this one, because you are collecting all the terms. So 1, 3, 4, 5, 6, 7. So the conclusion here I want to give is, this is what the point I wanted to make you understand, that the AND operator is equivalent to the intersection operator of set theory. OR operator is equivalent to union operator of set theory. So whenever you get any questions where functions are defined, different functions are defined with respect to certain mean terms or max terms, and you are supposed to find the mean terms or max term of another function which is related to these functions. So this concept is very handy. You can simply make use of the union intersection concept. It will be giving you the final answer. I hope this logic is clear to all of you, isn't it? Now we said all these things, friends. Now one more model of question that we need to tackle is how to find the mean terms and max term of a function. So this is the questions: obtain the mean terms and max terms of these given functions. So I want to find mean terms and max terms. So you see, students, so the first function f, this is in SOP form. If it is in SOP form, we'll be first getting the mean terms, and from the mean term data, we'll be accessing the max term data. We know how to do that. Second function is in POS form. So from POS, we can get the max term first, and from max term, we'll be accessing the mean terms. So that is the actual process. If you go by book approach, it is very lengthy. So I have one equivalent shortcut techniques. So directly I'm discussing the shortcuts without going to the actual these things, how to get it. I'll give you some idea also how the actual thing happens. See, while finding the mean terms, we have already defined what is mean term. That each term in the canonical SOP is known as the mean terms. Okay, each term in canonical SOP is known as mean terms. So first step is you have to convert this into canonical form. How to convert into canonical form? Let me solve otherwise in the general conventional methods. Then I'll tell the shortcuts. So here you see that f is b, and then it is a bar C bar. Intentionally I am writing with some space, and then you have A bar B C. So in the canonical form, we expect every variable should be present in every term. So there is nothing wrong if I introduce here A plus A bar and here C plus C bar, because A plus A bar is 1, C plus C bar is 1. So 1 dot B dot 1 is B. So because AC variable are missing, so I have introduced this. In the second term, your B is missing. So here I am writing it is B plus B bar. So this is one bracket term, this is one bracket term, and this is the other bracket term. Now if I expand it, what you get? AB plus A bar B, and this is C plus C bar, plus this is A bar B C bar plus A bar B bar C bar plus A bar B C. If you write it out, ABC plus ABC bar plus A bar BC plus A bar BC bar. I have just expanded this one. AB with C, AB with C bar, A bar with C, A bar B with C, A bar B with C bar. Then you have your A bar B C bar, then you have A bar B bar C bar, then you have A bar B C. So this is 1 1 1. So Minterm means always, SOP means always variable is 1, variable bar is 0. 1 1 0, 0 1 1, 0 1 0, and it is A bar B C bar, right? So 0 1 0, 0 0 0, then 0 1 1. So this is 7 6 3 2 2 0 3. So always Minterm I plus Minterm I is equals to Minterm I. Similarly, Maxterm I ANDed with Maxterm I is equals to Maxterm I. So even though I have two repeat twice, so this one, but if you do OR combination of this, you again get the same variable only. Similarly, although 3 repeated twice, the OR combination of this and this is again this one only. So if I write its corresponding mean terms, so the answers are 0, 2, 3, 6 and 7. 0, 2, 3, 6 and 7. These are the mean terms. If I ask you what are the max terms, those terms which are missing, like 1 is missing, 4 is missing, 5 is missing. So these are the max terms. So this is what the actual process is. Like first you obtain the canonical form. So this was in standard form, you got the canonical form. And from canonical form, you are decoding it, what is the corresponding decimal equivalent of their binary combination, you are getting this answer. But how to get the same answer without doing all these things? Okay. So that is what the shortcut I want to tell you. So you understood this is a bit lengthy. Now you see if you go by my shortcut techniques, so how you are able to reach the conclusion. All right. So for that, what I am doing is, so I am writing the term B. So you have one term B. What are the term missing? A is missing, C is missing. So I am putting blanks. And next your A bar is present, B missing, I am putting blanks. Then you have C bar. In the last term, all are present, so nothing needed. Right? So this is how but you need to always maintain the sequence, student, because in the function the sequence is ABC. So A, then B, then C. So you are not supposed to do a mistake. This is B, this is AC. This will be a mistake. So whatever the sequence is given in the function, so that you have to maintain, because clearly in the function A is defined as MSB, C is LSB. So that pattern you have to maintain. So that sequence you should always follow. Then if you have two blanks, using two blanks, how many combinations you can write? 2 power 2, 4. So write 4 combination, 0 0, 0 1, 1 0 and 1 1. And B is 1. In the SOP, variable is 1, variable bar is 0. So this is what? Over. Next A bar C bar. So you have one blank. One blank means two combination, 2 power 1, 2. So this is 0 and this is 1. Variable complement means 0, variable complement is 0. And here it is variable complement is 0, variable is 1 and this is 1. So what are the decimal equivalent of this binary? 2, 3, 6 and 7. So 2, 3, 6 and 7. This is 0 and 2 and this is 3. So these numbers you take it out. So simply the mean terms would be how much? 0, 2, 3, 6, 7. Those numbers are repeated twice, thrice or 4, 5 times. You take it only once. So 0, 2, 3, 6, 7. You see the same answer I got here. So to reach this conclusion, you see how much of like effort we have done, and that to be, if the function is again having some more terms, you imagine how much time taking that process will be. But this process is very straightforward. This is the approaches. So whenever you have the function in SOP form, you can do this. You can get the mean terms. From there, you can get the max terms. Similarly, for the max term case, also we have to follow the similar approach. So here you see, students, you have A missing, you have B bar plus C bar. Next, you have A present, B missing, C missing. Next, you have A bar plus B bar, so C missing. And at the end, you have all A, B, and C. So in max term notation, variable bar is taken as 1, variable is taken as 0. In max terms, this is the pattern. So here I have only one vacancy, so I can have 2 power 1, 2 number of combination, 0, 1. So B bar, so not to forget, we are dealing with max term, so variable bar is 1. So 1, 1, so that is constant. Here I can write 2 means 4 combination, and it is A means variable is 0, so I am writing here 0. In place of A, I am writing 0. That variable which is present, you simply write its value, 0 or 1, depending on what you are dealing with. Similarly, here also I can have 2 combination. A bar, variable bar means 1, 1. A, B, C, variable means all zeros. So now you find the decimal equivalent of this. So you get 3, you get 7, you get 0, 1, 2, 3. Here you get 6, 7, and here you get 0. So that means if I ask you, but remember, the answer you are getting is in the max term form, because the question was in the pos format. If it is SOP, you get mean term. If it is pos, you get max terms. So max terms are 0, 1, 2, 3, 0, 1, 2, 3, then 6, 7, 6, 7. These are the max terms. If these are max terms, what are the mean terms which are missing? So 4 is missing, 5 are missing. So this is the mean terms. So max terms are 0, 1, 2, 3, 6, 7, and mean terms are 4, 5. So this is what the approach you are going to take whenever you get such questions. What are the mean term, max term? This process you can follow. So even if it is for 3 variable, 4 variable, 5 variable, you can get the answer in a very short span of time if you follow this approach. One gate question, student, which is asked in one of the electronics paper. So let us see this. This is GATE 2015 electronics. A function of Boolean variable xyz is expressed in terms of mean terms as f of xyz is 1 to 5, 6, 7. Which one of the product of sum give below is equals to function f of xyz? So you want what is the equivalent pos expression of this? So if 1, 2, 5, 6, 7 are the mean term, then naturally I can access the max terms. The missing variables 0, 3, 4. These are these things, max terms. So this is equivalent to max term 0 ANDed with max term 3 ANDed with max term 4. 0 is 0, 0, 0, 3, 0, 1, 1, 4 is 1, 0, 0. So in max term notation, 0 is variable, 1 is variable bar. So 0 is variable. So here you get x plus y plus z. Then you get x plus y bar plus z bar. Then you get 1. 1 means x bar plus y plus z. So first of all, here students, because 5 mean terms, 3 max terms, so naturally option A cannot be answered because it is having 4 max terms. This is impossible. Even option C also eliminated. This cannot be answered. Even this is also eliminated. So here, even without doing this much thing also, I can tell the answer is B, because if it is having 5 mean terms, I know that I have 3 max terms. So 3 sum terms should be there. So 3 terms are not present only in option B. So B has to be right answer. And if you want to know how this is happening, this is what the logic is. X plus y plus z, this one. Then x plus y bar plus z bar, this one. Then x bar plus y plus z, this one. So answer is option B.